We've just received striking new visuals of 3I Atlas, the third confirmed interstellar visitor ever detected from Earth, currently hurtling through our solar system. Recently, astronomers captured the event live, broadcasting it in real time. Alarms erupted at NASA's Jet Propulsion Laboratory. Telemetry from the Deep Space Network spiked chaotically, then went completely dark, as something violently intercepted 3I Atlas. What was once a source of scientific fascination became a victim of an unseen force, triggering an urgent and extraordinary emergency assembly at NASA. Our foundational assumptions about space have been shaken, exposing a terrifying vulnerability. In this report, we'll examine exactly what occurred, why it's shaken the global scientific community to its core, and why humanity may now be facing a cosmic threat we are wholly unprepared for. At first, the incoming data was baffling, borderline inconceivable. Instruments recorded an enormous, immediate surge of energy, comparable to a cosmic explosion, followed by a sharp, sudden deceleration, violent in nature. Almost instantly, the comet's characteristic tail, a dazzling stream of green and blue that usually spans hundreds of thousands of miles, shattered into a chaotic swirl of particulate matter, dispersing through space. This wasn't the result of solar wind erosion or gradual gravitational forces. It was a rapid, destructive event. Observational probes trailing the comet, intended to collect data on its composition and origin, abruptly lost contact. From steady transmissions to total silence in a blink. What's most disturbing is that the incident defied every known natural astrophysical mechanism. Scientists have spent decades cataloging and studying countless objects in our solar system, from small rocky bodies to frozen comets, developing solid models of their dynamics and behavior. But the attack on 3I Atlas was unlike anything previously observed. It was as though an invisible force had reached out and crushed a delicate object mid-flight. The magnitude of the energy unleashed was staggering, estimated to match thousands of megatons of TNT. Yet no precursors were recorded. No solar flares, no rogue black holes, no anomalies flagged in our existing predictive systems. Data analysis revealed distinct collision patterns, but with no identifiable culprit. The vastness of space, spanning light years, makes such an encounter almost infinitely improbable. 3I Atlas, traveling at around 100,000 miles per hour, was considered a solitary object. The probability of it randomly colliding with something massive enough to cause such devastation and leave no trace is almost nil. What's often overlooked is the sheer scale of the object. Though labeled a comet, 3I Atlas was no small stone. Scientists estimated it to be approximately half a mile in diameter, a formidable mass of ancient rock and ice. For such a body to be obliterated so abruptly, it would require an impacting force of massive proportions, or a type of energy release that surpasses our current scientific understanding. The speed and finality of the event allowed no warning, no time for deviation or response. It was an ambush, sudden and brutal in the silent void of space. Processed imagery through the dispersed wreckage revealed a comet not just broken apart, but ripped asunder. The once solid core had splintered into large fragments, surrounded by countless microscopic shards of ice, all glinting in reflected sunlight. It resembled a cosmic detonation, yet with no signs of an internal explosion. The universe has always been full of the unexpected, but this incident felt intentional, almost precise. The rapid destruction pointed to an external source, a swift and concentrated strike. The question isn't if something hit it, but what and how. This was no light graze from debris. It was a calculated, catastrophic strike. What caused it remains entirely mysterious, prompting an urgent scientific scramble for answers. The more researchers reviewed the event, the stranger it became. Astronomers have long been intrigued by interstellar objects, those rare emissaries from distant solar systems. Like its predecessor Oumuamua, 3I Atlas offered a rare glimpse into material originating beyond our own system. These visitors are of immense scientific value. They contain information from alien star systems, carried across light years of space. 3I Atlas was especially valuable. It exhibited active outgassing and a clearly defined tail, making it a true comet. Oumuamua, in contrast, was a cigar-shaped body that never displayed any traditional cometary behavior, sparking wild theories, including extraterrestrial ones, before being explained through more natural phenomena. 3I Atlas, however, fit the cometary mold perfectly until it didn't. What separates this event is not just the sudden destruction, but the complete absence of explanation. When comets or asteroids break apart, there are generally obvious causes: solar proximity, gravitational stress from a nearby planet, etc. But 3I Atlas was far from any major body, over 400 million miles from Earth, in the outer regions of the solar system, well beyond Mars's orbit. At that distance, neither solar heat nor gravity could account for such a rapid and total disintegration. Even more chilling is the lack of any visible impactor. Our current space observation tools, from orbital telescopes to ground-based radar, are capable of detecting objects even smaller than a softball in near-Earth orbit. For something to strike and destroy a massive comet without leaving a trace defies logic. This suggests two unsettling possibilities: either the presence of technology far beyond ours, or the involvement of a natural cosmic phenomenon so rare and exotic that it eludes our current frameworks of physics. Even our most advanced instruments, such as the Hubble Space Telescope and the James Webb Space Telescope, designed to observe the earliest light in the universe, saw nothing approaching 3I Atlas before the impact. It simply existed, then didn't. People often jump to alien explanations. While most researchers lean toward natural theories, the extraordinary nature of this event pushes the limits of traditional reasoning. The focused intensity of the energy release and the uniformity of the debris field suggest a targeted action, not a random explosion. It wasn't a messy burst. It was clean, direct, and powerful. Even more baffling, there were no lingering gravitational anomalies, no detectable electromagnetic signals. It's as if whatever hit the comet vanished, leaving only devastation behind. This incident forces us to ask an unnerving question. Is space more dangerous than we ever imagined? Humanity spends billions tracking near-Earth objects, developing planetary defense systems against known threats. But this wasn't a near-Earth object. It was a visitor from deep space, and it was destroyed by something unknown. Worse, our defense systems are built on the idea that we can see threats coming. But this was an assault by something we couldn't even perceive. The implications are enormous. At NASA's emergency meeting, anxiety replaced protocol. Director Thorne, known for her unflappable demeanor, walked the room with a tense expression. Warning screens flashed, not of an imminent impact with Earth, but of something much more alarming: the end of the illusion that space is predictable. "We are not prepared," she said again. The words lingered in the room. The real concern wasn't just the loss of a comet, but the utter incomprehensibility of what caused it. How do you defend against a force you can't see, detect, or comprehend? Some of the brightest minds in astrophysics, planetary protection, and theoretical physics were present. Typically, lively debates gave way to grim silence. Ideas were raised, only to be dismissed in cold realism. Sending a new probe to investigate the wreckage would take months or even years, and by then, the debris would be too dispersed to study. Could older data be reanalyzed for missed anomalies? Possibly, but it's the proverbial needle in a haystack. The event exposed a critical vulnerability: our blind spots. Despite cutting-edge instruments like Chandra or XMM Newton, our tools only pick up known signals: visible light, X-rays, radiation, gravitational effects. Whatever destroyed 3I Atlas produced none of these. It was like a ghost, passing through undetected, yet leaving catastrophic results. A new cosmic reality. Our observation systems, while groundbreaking, are limited by the laws we currently understand. If a phenomenon exists beyond that scope, we simply don't see it. Humanity's entire planetary defense budget, although growing, is built around predictable threats: asteroids, comets, solar storms. We've theorized ways to redirect or destroy known objects. But this wasn't something we recognized. This incident marks a paradigm shift. We've always viewed space as vast, mostly empty, and governed by consistent laws. The obliteration of 3I Atlas implies a universe that's less stable and potentially more hostile than previously believed. This meeting wasn't a strategy session. It was a reckoning. The brightest minds faced a terrifying realization. We are flying blind. The phrase "we are not prepared" wasn't hyperbole. It was a warning. A call to rethink everything. Could Earth be just as vulnerable as the comet? What if next time we're the target? Rethinking the universe. This incident has completely reframed how we think about space. 3I Atlas wasn't just a comet. It was a symbol of what we don't understand. These rare interstellar objects originate from distant stars, ejected by gravitational upheavals or cosmic collisions. They are truly alien wanderers. To see one destroyed, not by a planet or a star, but by something unknown, introduces an entirely new class of cosmic threats. Speculation about alien civilizations will always exist. But scientists are also considering exotic natural phenomena, perhaps a localized burst of dark matter, or interaction with unknown particles. Could a microscopic black hole, smaller than a pinhead yet infinitely dense, have passed through it? It's possible. Our knowledge of the universe is still rudimentary. What makes this so challenging is that no current theory can fully account for the speed, violence, and cleanliness of the event. We tend to think of the solar system as mostly empty, a shooting range of harmless dust and occasional rocks. But 3I Atlas shows us that interstellar objects, those formed outside our solar system, might behave in ways we haven't prepared for. We base our models on our limited experience, our little corner of the cosmos. But the space between stars? That's the real wild unknown. How can we ensure the safety of future missions to Mars or beyond if these kinds of threats lurk unseen? Missions that span years, even decades, could be in jeopardy. This isn't just a bizarre footnote in space history. It's a warning sign, humanity's wake-up call. This event exposes how technologically underprepared we are. We've accomplished wonders, roving distant planets, capturing light from the edge of the universe, sending probes billions of miles from Earth. But we couldn't detect a destructive force that obliterated a half-mile-wide comet inside our own solar system. That should terrify us. The truth is, if it doesn't emit light or radiation, we can't see it. What if the universe is filled with threats that don't play by our rules? It's like guarding a locked door, while an unseen danger walks through the walls. We urgently need new tools, new detection technologies, new theories, new eyes to see what currently remains invisible. The destruction of 3I Atlas isn't the end of a mystery. It's the start of a cosmic awakening. Are we alone in the universe? Or worse, are we not? But perhaps the most unsettling part of the 3I Atlas event isn't what we know. It's what we now realize we don't. The universe has always harbored mystery, but this incident has introduced the idea that there may be active threats moving through space, unbound by natural law as we understand it. And worse, we might already be in their path. If a massive interstellar comet can be obliterated without warning or explanation, what else is vulnerable? What else might already be under observation or even targeted? Scientists are grappling not just with a scientific anomaly, but with a philosophical crisis. For centuries, our explorations of space have been guided by curiosity, not caution. We assumed the universe to be passive, indifferent, perhaps, but not malicious. But now, that assumption feels dangerously naive. If something out there has the power, and possibly the intent, to destroy celestial bodies in transit, we must ask, what are its goals? Is it watching us? Could we be next? This isn't the script of a science fiction thriller. This is a real event, recorded, analyzed, and confirmed by multiple independent observatories and agencies. Yet the lack of tangible evidence has driven a wedge between traditional scientific reasoning and a growing community of voices urging us to consider uncomfortable possibilities. Some whisper about intelligent design, others about undiscovered cosmic forces, or even unknown dimensions of physical interaction. But whatever the answer, it demands we expand the scope of our imagination and our technology. Already, think tanks and defense contractors are shifting their focus. New proposals are being drafted for experimental sensors, able to detect gravitational anomalies or exotic particles previously ignored. Prototypes for deep space early warning systems, once theoretical exercises, are now moving up the priority chain. The truth is stark. We need to develop tools not just to look deeper into the stars, but to sense what may be hiding between the wavelengths, in realms our eyes and machines can't currently see. Even cultural reactions have begun to shift. The public, once enchanted by tales of space exploration, now watches with unease. Online forums buzz with speculation, and the phrase three-eye atlas has already become shorthand for cosmic vulnerability. It has joined the lexicon alongside Oumuamua and Tunguska, unexplained space events that leave more questions than answers. But unlike those, this wasn't a close call or a silent pass. This was a violent act committed in the open theater of space. Governments are responding slowly, but noticeably. High-level briefings have been held behind closed doors, and certain astronomical data archives have quietly gone offline for review. The lack of transparency only fuels speculation. Some fear the implications are too enormous for public disclosure, while others believe officials simply don't yet know what they're dealing with. Whatever the reason, the silence has only deepened the sense of global unease.